This is Algebra 2 with Trig, Unit 1C.0. We're focusing on conics. We're working circles. And we start out with what a circle is. It's a set of all points that is equal distance from a fixed point. The fixed point is called the center of the circle. And the distance, we often call it r, between the center and any point along the circle is the radius. So when we talk about an equation of a circle has two parts. It has the center and it has the radius. So we can come down and see what the equation of a circle is and how it's made. It's originally made from the distance formula. We know that the distance formula is typically x2 minus x1, and we square that, plus y2 minus y1, and we square that. And then we take the square root to get the distance by itself. So that's your distance formula that you're used to, trying to figure out the length of the radius. But if we square both sides, we're no longer calculating just the radius. We now have a radius squared, but we know where the other parts are coming from. If the center, in fact, is 0, then we're all the way down to x squared plus y squared. We don't have any h or k value. So there is our basic form of an equation of a circle. X minus h, now we're dealing with a center that's different than the origin. You've worked with x minus h before. Y minus k. We're putting that all on the same side of the equal sign from the r squared. So it's very similar to the circle formula we had up here. And you can see the difference is, instead of having zeros for your h's and k's before, because the center was at 0, we now will have numbers in place of those. So if we come down here to our first equation, we're going to be looking for our h and k and what the r value is, what our center of the circle is and what our radius of the circle is. We look at our equation and we see that it's not even in the correct format. We're supposed to have the x squared and y squared on the same side of the equal sign. So we're going to need to move that over first. So let's first move the 4. That'll go to the opposite side. Then we can add the y squared back across. And you can see that we've manipulated this equation so that it's back into what we might call a standard form of a circle. From our standard form of the circle, we can see there's no parentheses, there's no h or k value being added or subtracted from y's, so our center is at 0, 0. It's just x squared plus y squared. That implies that we are at the center of the circle. The radius, from our formula, r squared is the 4 part. That's what our formula says, is that r squared is what your equation equals. So r squared equals 4. So when you take the square root of both sides, we'll figure out that our radius is 2. Mathematically, when we take the square root of that, we'd have plus or minus 2 when you take the square root of an equation on both sides. Plus or minus 2, but because we're working with geometry, we're working with distance, we're not dealing with the negative version of your radius. Here we have our equation. This time it has more to it. If you notice, it has parentheses. This one is in the format of x minus h squared plus y minus k squared equals r squared. If you notice, in the equation it says x plus 2, but the formula is x minus h. So that means that the h value had to be a negative 2. A negative times the negative 2 is going to make the equation look like a plus 2. And then, of course, the k value is going to be 1. So your center is negative 2, comma 1. And our radius squared is 9, so when we take the square root of both sides, we're going to have a radius of 3. So if we were going to graph both of these equations, we would start at our center. Let's slide back to the first one here. Our center's at 0, 0, and we're going to go a radius of 2. So that means we're going to go up 2, to the left 2, down 2, and to the right 2. You don't have to worry about all the other directions. That might be difficult to identify just where 2 is. And we can come around and draw in our circle. You should label your graph with your equation. So there's our x squared plus y squared equals 4. Circle, the equation of a circle does not specifically have a parent function, since the radius will keep changing. But the most basic form is going to be x squared plus y squared. But the radius will keep adjusting. So the radius could be 1, the radius could be 1.5, it could be 2. So this type of equation doesn't specifically have a parent function. You might call the most basic one the unit circle, which you'll learn more about that in second semester, and that's with the radius of 1. So here we have our h and k, which is telling us that our center of our circle is going to be over 2 and up 1. And a radius of 3. So we go up 3 more, go to the left 3, go down 3, or to the right 3. And we should write our equation onto the graph as we have for other types of graphs we have done. Now we'll come down and take a look at writing an equation if you're given a radius and the center. Not overly complicated, but you do need to know what your parts are. If you think about your equation, the standard form of your equation, for us to write an equation, we need to know what the center is, the h and the k, and we also need to know what the radius is. Those are the two parts of what you need to know for an equation. So we have x minus 0 and y minus 0, and our radius is 4. So we'll square our 4. So here, x minus nothing squared just gives us x squared. Y minus nothing squared just gives us y squared equals 16. So there's our equation of a circle given a radius of 4 and a center of 0, 0. We would have the same idea I would suggest starting out with your formula. Just helps you know exactly where you're plugging in your values. Here we have a center at negative 5, 7, so that is your H, and that is your K. So we're going to take X minus a negative 5. So your H value is negative 5. You should plug that negative 5 into the parentheses. Then Y minus the K value is 7. So in the equation it just looks like a minus 7. And your radius is the square root of 3. And we have to square the square root of 3. X plus 5 squared. Y minus 7 squared doesn't change. And when you square square root, you get the number that's inside. Squaring a square root is going to eliminate the radical. Moving on to the next one. Here again we have a center, and the center is HK. So you're going to take your equation. X minus H squared plus Y minus K squared equals R squared. You go ahead and fill in your values. Pause the video and check it out. So I know that my H and my K, X minus H, my H is 0. Y minus K, my K is negative 9. So notice how I have it in parentheses. And my radius is 2 root 6. And that radius is going to be squared. So we have X minus 0 squared. So that's just X squared. Y minus a negative 9, or a Y plus 9. When you square 2 root 6, you square the 2, and you square the root 6. Different ways to think about this. You could call that the square root of 36, or when you square square root, you get what's inside. So now you have 4 times 6. X squared plus Y plus 9 squared equals 24. So that had a couple more steps to it. But overall, circles typically aren't very, very tough. See what you think about that. Look at your equation. We plugged our numbers into our equation to figure out the equation of our circle. All right, here we're looking at the situation of having a point that lies on a circle with the center at the origin. So we know our point is considered x comma y. Our origin is our center point, our HK, and that's 0, 0. So if you're going to start with your equation, it's always good to start out with your equation and plug in the values you know. What we don't know here is our radius. So we're trying to calculate what our radius is. But we do know the x, and we actually know what the h value is because the center's at the origin. We know it's 0. What we don't know is what the radius is. So that's the part we're going to be solving for. So we get negative 4 squared, which is 16, 7 squared, which is 49. So that's coming out to be 65 for your r squared. Now we finally have solved for what the radius is. We did that by plugging in the point that's on the circle and plugging in our center point. That allowed us to use the distance formula. Essentially, that's what that was, right? just the distance formula. So we have x squared plus y squared equals 65. So you go ahead and try the next one. We'll pause the video to give you a chance to try it on your own, and then you can come on back and see us do it. So we have a point that's on the circle. That point on the circle is your x and y. The origin is your h and the k. Your origin is the center, so we know it's 0, 0. So if we know we're at 0, 0, we could really just use x squared plus y squared equals r squared. We don't even have to deal with the minus 0 part. So we have 3 squared, we have negative 4 squared. That gives us 9 and 16. That gives us 25. So x squared plus y squared equals 25. Here we have a point that's on the circle, and we have our center. So we have our x and y, we have our h and k. So using x minus h squared plus y minus k squared, that equals our radius squared. So now our x value is 5, and our h value is 7. Our y value is negative 3, and our k value is negative 2. We still don't know what the radius is. We've got to solve for something, so we're solving for our radius. Here we have negative 3 minus a negative. Negative 3 plus 2. When you minus a negative, you're actually adding. So negative 3 plus 2 gives us negative 1 squared. That is 4 plus 1 equals r squared. So r squared is 5. So we're going to say that this is x minus 7 squared and y plus 2 squared equals 5. We can look inside our work to see what our equation is. Up here we plugged in our h and the k. So we had this x value minus 7. So when I wrote my equation, I knew it was x minus 7. Here I had my y value plus the negative. So I knew it was plus. It was plus 2. So it was y plus 2. And our r squared, of course, was 5. You go ahead and try the next one. Pause the video, come back and check us out. When we look at this one, we see it's a little bit different. We're going to write our equation. To write an equation, you know that we need to have the center of the circle, which we have, our h and the k. And we also need our radius, and our radius is 2 root 7. So we're ready to go right into our formula to write our equation. Our h value is 5. Our k value is negative 3, so we have to put that in parentheses. And our radius is 2 root 7. Well, this is your radius squared, so you have to square your radius. We always square our radius. Usually we're solving for the radius. In this case, we actually got to square the radius. So this is x minus 5, quantity squared, y plus 3, quantity squared, and we're going to square the 2 to get 4. We're going to square the radical to get 7. You get the value inside when you square square root. So x minus 5 squared and y plus 3 squared equals 28. We're going to write a standard form of an equation of a circle that passes through this point and has a center at the origin. If the center is at the origin, we don't have to worry about your h and k. H and k would be 0. So the point that it goes through is your x and y. Gives us 25 plus 1. So the radius is 26. Radius squared is 26. So x squared plus y squared equals 26. And the last one here, we're going to write an equation of a circle with a radius of 3 and a center. Your center, again, is your h and your k. So x minus h squared plus y minus k squared equals r squared. The more time you write out your formula, the more times you'll be familiar with it. So we have x minus negative 11 and y minus 8, and our radius is 3. Three squared is 9. So you got to square your radius value for your equation. And there it is. And on this particular date, this is showing this to be a review of a parabola that deals with a focused value. We have not learned the focus value, so we're going to let those notes go.